This video is covering 7.3, simplifying expressions with exponents. You should have already watched the video 7.1 where we covered zero exponents and negative exponents. So in this lesson, we're just going to take it one step further and just look at some more complicated expressions with exponents and simplifying them. Okay, so looking at example 1, we have 3 parts. So what this means is the parentheses means that we're multiplying each of these parts together. So we want to simplify this expression down to like one term or one single group. Okay, so what I'm going to do is we're going to break this down first of all, and I'm going to call this one red. We're going to use green for this one, and then we'll use blue for this one. All right, so we're going to break this down into its individual groups. So the first group is 3x squared. If you were to break down 3x squared, I'm going to use red now, that would be 3 times x squared is x times x. Okay, then we move on to the next one, the green one, 2 times x to the negative 3. Now we talked about this in the last lesson with the negative exponent. So the 2 does not have the negative exponent, so it's going to stay in the top of the fraction. Then the x to the negative 3 moves to the bottom and becomes positive. And the x cubed means x times x times x. Okay, so the negative makes those 3 x's go to the denominator. Then our last one in blue is 5x to the 6. So that means 1 5 and then 6 x's. Okay? Alright, so we've broken each of these down. So now what we're going to do is we're going to bring them all together. And now I know that you have these fractions, so if you want to think of it, you don't have to do this, but if you want to think of the red as like over 1, and then also the blue is like over 1, you can do that if you want to. So what I want you to see is, first of all, we have these numbers. We have 3, 2, and 5. And I want you to look at the placement of those. 3, 2, and 5, they're all in the numerator. So what that means is we can just multiply those 3 numbers together, and then the result would be in the numerator. So 3 times 2 times 5 is 6 times 5, which is 30. Okay? Then we look at our x's. Now here's what happens. Remember when you do like unit conversions, if you have like feet in the numerator and then you have feet in the denominator, they cross out. It's the same thing here. So if I see a 1x up here, then I can cross out another x down here. Okay, I can do that again. I see an x up here, I see another x down here. So you have crossed out 2 x's in the numerator and 2 x's in the denominator. Now we can move on to the blues because I have one more green left in the denominator. So one more green crossed out in the denominator crosses out 1 in the blue section. So now you can see that I don't have any more x's in the denominator, so I can't cross out any more. So now I see, okay, how many x's are left? Well, I've got these x's left. And how many are those? 5. So that's x times x times x times x times x. So that's x to the 5th. And then all you have left in the denominator is 1. So then we just leave the answer as 30x to the 5th. Okay. Now, some of you may see a shortcut before. You've seen this before. And I'm okay with you using some tricks, which we're going to talk about in class next. But for now, as we're kind of learning this process, I want you to be writing all of this out for these notes, okay? So now for example 2. Let's try one that looks a little different. So a little simpler, actually. So we have 3x squared, and then that to the 4th power. So what that means is, if you're raising something, that whole thing in parentheses is to the 4th power, that means that whole parentheses, 3x squared, gets multiplied 4 times. So we're going to write it out. Actually, I made a mistake there. That should be 2. 3x squared 3 times, and 1 more time. Okay? And then we can kind of break this down even further, because 3x squared is 3 times x times x. So I'm going to do this again. I know this process is tedious, but I want you to do this for now. Later we'll learn kind of a shorter way to do things. Okay, so then you can see that I want to multiply just my regular number together. So 3 times 3 times 3 times 3. So that's 3 to the 4th. which is 81. And then you just count, okay, how many x's are there? 1, 2, 3, 4, 5, 6, 7, 8. So that would be x to the 8th. Okay? And that is my answer. That was a little bit easier because we had no negative exponents to deal with. Okay, we're going to do 2 more examples. And what I want you again to be thinking of is think about like the shortcut. Think about what the rule would be, which is what we're going to talk about in class next. So let's go on to example 3, which is going to look like 6x to the 4th, y to the negative 3 times 4x to the negative 1, y cubed. So we're going to throw in some more negative exponents here. My recommendation is to take care of the negative exponents first before you start combining them together. So I'm going to rewrite this as 6x to the 4th over y cubed, because that negative 3 makes the y go to the denominator and become positive. Then times 4. Now the x, the negative, makes that come to the denominator. And then the y cubed is positive, so that's going to stay in the numerator. Okay? So now I'm going to expand out. So that's going to be 6 4x's over 3y's times 4 times 3y's over x. Okay? Now you start looking at things that you can multiply and cross out. Oops, sorry. There we go. Alright, so I have my 6 and my 4, which are both in the numerator, so that's nice. So 6 times 4 is 24, which is going to be in the numerator. Then, let's look at our x's. I've got 4 x's in the numerator and 1 x in the denominator. So I can cross out 1 in the top and 1 in the bottom. And there's no more x's, so this group of x's is going to go together and become x cubed in the numerator. Now let's look at the y's. I've got 3 y's in the denominator, 3 y's in the numerator, so they actually are going to all cross out, leaving me with no y's. So look at the bottom, I have nothing left. That doesn't mean it's 0. That means in the bottom I just have 1. So then my answer is 24x cubed. Okay, so again, look at my original question and think about how you could quickly get 24x cubed without expanding. All right, we're going to do one more example and then we're done. So example is 5x cubed, y to the negative 1 squared. Okay, so like I said, the first thing I'm going to take care of is my negative exponent. So I have 5x cubed. The y to the negative 1 makes you have a y in the denominator. And y to the first power is just 1y, so we're going to leave it like that. And then that's squared. So now, I'm going to take care of my outer function first, which is the squared. So I'm going to multiply 5x cubed over y, and then that's squared, so 5x cubed over y again. Now I'm going to expand these out. So 5x cubed is 5 times x times x times x over y times another 5 times x times x times x over y. Okay, let's combine. So in the numerator, I have 2 5's. So those 2 5's are going to multiply together to give me a 25 in the numerator. And the x's, you see all my x's are in the numerator. There are none in the denominator, so you actually can't cancel anything out. So if you count, I've got 1, 2, 3, 4, 5, 6 x's in the numerator, making that x cubed. Then for the denominator, you have the y's. And again, the y's are both in the denominator. There's none in the numerator, so nothing's going to cancel out. So that just leaves you with a y times y, or y squared, in the denominator. So this is my final answer. Okay? So again, I want you to compare that with looking at the very beginning question Oh, I'm sorry. I just realized I made a mistake. Sorry. It's not x cubed. That should be x to the 6. Remember, 6x is the numerator. My bad. Okay. So now look at the answer, and I want you to think about how you could quickly come to the final answer. Okay? And that is it.